Hello everyone, I'm Shogun. Let's continue looking at unicast. Actually, writing it this way here is still not great, because it leaks to the heap and never releases unless you close your application. So I think this way of writing is not good. Let me add a note. Wait, let me add a note. We do not recommend writing it this way. There will be issue. Now let's look at what the next delegate is bound to. It is bound to SP. It should be bound to A, something like a smart pointer. Then we can do it this way. We should write it like this. Here we will continue using our most original one. Then we call it SP. Smart Project. Let me spell out the name for everyone. Sometimes I don't really like it either. Sometimes I really hate these abbreviations too. If you don't use them often, you really won't know what this thing is for a while, what it refers to, and then it acts as this SP. Then we can see that it definitely needs to pass a pointer here. Fill in a function, and then just load the payload. Then we can do this. We can use TSharedPtr, or reference. And this is a smart pointer template. We want this object, and then we let it. Make share ref. You can see that what it outputs is this. Then we should be able to leave a note directly here. It should be fine to write it this way. Well, we haven't covered smart pointers yet. Let's see if this writing style is accepted. The struct. It seems we need to write it like this here. It doesn't seem to be written this way. We can take a look. Make sure the way of... Let's check the documentation at this point. It seems its copying method is like this. Yeah. This is this kind of pointer, because we haven't covered it yet. So now you might feel a bit confused when you see this part. That's perfectly normal. Actually, this declares a pointer, and this pointer will be managed through this lifecycle. Then here we run it, and we let its pointer pass this in, and we need to pass this method. It should be possible to write it like this. Just attach it like this. Obviously, we also need a payload here, right? Let's attach this payload to it. Okay, you see, compiling like this has no issues. And actually, the execution result here is the same. So here we should try to make it not written like this. We call it smart card location. Then let's remove this payload. We don't need it now, because we've already demonstrated the payload many times. So there shouldn't be any problem at this point. Without the payload, this percentage is low. We don't need it either, because if you use a low percentage, it might compile and report an error or give some error codes. And then the smart or Sion binding here does not require a load. Okay, so actually this is binding to a smart pointer to such an object. The advantage is that if this object, the structure, it won't have issues. That is, after this scope ends, there is only this smart pointer pointing to the object. So this object will be released for everyone's convenience. We will write its constructor and destructor here, and for the destructor, we needed to... This is about smart pointer knowledge. In our context, we'll just write it down for now. Okay, so here, let's add a log. Okay, I'll use Chinese here. Okay, like this, a bit more standardized. Then, when we test it later, you'll notice that this method never gets destroyed, but this one gets destroyed immediately, so we're demonstrating it here. Actually, oh, it seems we missed something here. We missed a method. We can use cancel here. It needs to be canceled at this point. So we can only check it here. Here we still write this method. smart 기본대. Okay, when it executes, let's take a look at its implementation. Note that here we are copying this, my pointer. Sometimes it's easy to make a mistake. That's also very normal. Okay, now let's execute it. Of course, if we execute it now, it definitely won't work because this object, after it goes out of the scope, this smart pointer, it has been released. Then this object has no smart pointer to protect it, so it will be destroyed. Then later we will copy a smart pointer. This way it keeps holding the object. Okay, it's now started. Now note that we first execute our original function. We can see it here. Okay, we haven't actually done anything yet. And here it constructed, destructed. So what is the reason for this? It's because it was constructed here, no problem. And it was also constructed here, no problem either. Then after this effect, volume is released. It is released, and it is not released. So that's what it means. Yeah, then you will find that if we are here, we go here. So we can make it call smart object. It is actually very similar to our up. Do you feel it? Do you feel that feeling? Then we press 1 and nothing happens, right? It's actually very similar to our up parity. How do we do it here? So here we declare a smart pointer. Yes, we cannot declare this reference here, because a reference must have a value. Actually, this side is a null value. Active. Then we, in its smart struct. Okay. Then after we do it like this, it is actually in a null state now. After we finish here, we make a copy of this. It can be copied directly here. Yes, because we are sharing references. We can directly convert back to this pointer, so it can be directly converted over here. This is something we will cover in the last 2 chapters. This thing is very important. It is far more important than anything. It is basically something you need to advance. Made is a pointer that you must master. You should treat it as a special pointer for now. Then let's execute it again. Then let's directly execute it here. You will find that it did not execute the destructor. For it to truly execute the destructor, this actor must, after releasing this smart pointer, because of its reference counting mechanism. So we execute it once more like this. You will find the smart location here executes normally. As for this binding, it binds to the smart pointer method. Roughly, it is done like this. This is a very important practice. This kind of thing is often used in our slate. What is slate? It is the underlying layer of UMG. You can see that the entire Unreal Marketplace, Epic's launcher is written in slate. And the underlying editor is all slate. Okay, let's continue looking below. Let's look at this Lambda. Actually, this Lambda is also very interesting. Click on it, and you can see this floor is actually bound to A. It's also this shared pointer, but it's a delegate. So how is this Lambda used? You can search directly like this. You'll find it's actually used like this. The difference is that this function does not. Meaning, this function is not this struct. This function inside this struct. This counterflow thing is very powerful. We often use it for flow control. So, actually this thing, the usage of this Lambda is to write this function as an anonymous function. That's what it means. Then we can also continue writing like this. So here, it might need to pass a pointer. Why does it need to pass a pointer? It could be because it needs to capture some context. Having captured these attributes, it might be an address of some references within the pointer. So here, it must use, he's using this Lambda here. We can change it here. SM, then Lambda. There's probably nothing more to say about this part. You can capture many properties here. Capture some addresses within the smart pointer or some booleans. That's roughly how it's used. You can see this part, this is a pass parameter. This is related to the function signature. Then I'll just give a quick demonstration. It is mainly convenient for capturing values, because when you bind a struct, you can only do it through payload. Binding it this way makes capturing very convenient. Then we can add another method like this. This audio image won't go away. That's strange. This might be another minor issue with the text implementation. If we let it execute, it actually seems like in this place. This proxy doesn't seem to work this way. Then we'll have to change and start a new name. I've used this name too many times. I'm confused. Okay, then let's pick another one. Let's put it here like this. Then we do this. Okay, so this is okay. Then here, we do it this way. Change it. Okay, execute it here. This position. Here, we see that its creation method has not been created. The result of this execution should be fine. It should be executing this small large card. Let's see how many methods we have left. Actually, it's more or less the same. The remaining methods are all like this. Okay, then the next thing we need to do is here, right here. We will do it here. Then we just let it execute. Okay, observe this log. Pay attention. Hey, right, it just executed. That's how it's used. Then let's take a look at what else there is. What we haven't covered yet. As for thread safety, the static is a... Let's look at the comment board. This part is the binding. A global method that is bound. You can see. Then we can search for it. Look at this part. This part directly provides one. So how do we do this? We can write it like this. Let's write it here. If we call this method, we'll just call it readme static method. Okay, then it prints a log format. Sometimes when we are integrating the SDK, we use this kind of syntax. Later, I will teach you how to integrate some common SDKs. We will use the syntax. After writing it like this, we need a log. Let's write the log like this. It looks fine. And it's my static master. Just replace this part and it will be fine. Then we directly plug this method in here. Okay, you can see that this compilation passes, but we still need to add a delegate like this to make it easier for you to avoid some issues when you come back to review later. Replace the delegate here with this one. Then we write a square here. This is called call. Call my static method. This way of writing is very common. It's very common in CDX. Actually, when integrating the SDK, many times they like to write it this way. Just like writing a method like this. Very common. So this point needs to be emphasized specifically. Good. Okay, then let's execute it again like this. Then here, we'll just change this part directly. Here, that's it. Add another one. We'll still use this one. Okay, you'll notice it's consulted right. This word of ours seems typed wrong, missing letters, but it doesn't matter. No problem. Look, this place is still sucking. You can see that this place still isn't sucking, right? It's constructed. This sucking is caused by our smart pointer. But there's no sucking in this heap yet, so don't write it like this. It's a big problem. Okay, let's continue looking further. Let's take a look. What other methods are in this bundle object? Actually, this is the same, but it's mainly focused on thread safety. What does thread safety mean? Actually, it means you can use it inside a smart pointer. When it is declared, there is a declaration method called mased in as module. And here, there is a safe, and this is a thread safe declaration. And it's more or less the same. You see, that is, if it is not thread safe, it is very safe, right? If it is not thread safe, it is fast. Thread safe might be a bit slower. So you can make a declaration here. This is the self pointer we will talk about later. So actually, after this point, you can bind it like this. Then we won't do much testing here. Actually, let's still test it for everyone. We'll stop writing here. We'll delete this part here. Try not to modify the previous code. Save. Okay, we ran it again here. After running it, we just need to paste this here, flip it over, and here it's still the same. Because if you only use it within a single thread, you mean this struct describes the thing's NPC's current health value and health status. It only uses a main thread. Then you would be using thread unsafe code. Just set it to default. But this thing of yours, this instance controlled by your smart pointer, it might be interacting with other threads. For example, if you have some data in this thread, that needs to be updated in real time. After the update is done, as soon as another thread reads it, then at that point, you might need to consider thread safety. So we don't need to demonstrate this anymore, right? We'll just give it directly in a serve. This no longer needs to be demonstrated. The effect is definitely exactly the same. So we won't demonstrate it. We won't write this method. We'll still write this method, but we'll just not open the editor again. To do such a test, that would be too wasteful. Tool, time consuming. Okay. Create it. Then find it here. Execute. Okay. That should be about right. Okay. Then we won't do any further demonstration here. Let's continue to look at the following. See what else is below. There are some things here. Take a look. Zoom in a bit. Bring it out. So the bound object has already been found. We need to show you this bound function. As for this bound function, you'll find it's actually quite an interesting thing. It will pass an object ptr. We just pass race, and here we need to pass a function name. So we mean, here it passes a string. You can see that the engine doesn't have many such writing styles. That's it, it's bound through reflection. See, we haven't written this yet. As for the name, we haven't decided yet. Let's write this delegate first. Okay, let's call this single dimple 비근치 UFUNCTION. Then we need to write another method here. This method doesn't need to be called externally, but it needs to be of UFUNC type. This method needs to be called bind, call it my function. Okay, let's just call it that. Then we hit a log. Then we paste this log. This log is relatively simple. Bind from your function. So here we name this pipe. It can then execute. Then here we execute another test method called code myself your function. We start it like this. Okay, and when we do it this way, Okay, and here we just need to execute it. Okay, so that's done executing. This hasn't been replaced yet, right? Note to replace this part here, because we first check what else is there, and then note this place must have this UFUNCTION. If you don't have the UFUNCTION, congratulations, this thing just isn't bound. Look, take a look. UFUNCTION, UFUNCTION, UFUNCTION. Let me emphasize. And at the same time, it comes with a reference like this. Okay, let's go to our level blueprint. Then, after the level blueprint, we input XG. It actually has this smart object, something this big. And there's another XG here. This is our U function. Okay, let's just look at the U function. Okay, here it might run the construction one extra time during begin play. Okay, you can see the U function works perfectly fine. Then we executed it, and it had one destructor call. So where do these two destructions come from? Actually, they come from here. You will notice that we do not hold this pointer. Therefore, when it executes here, it will not execute this. We have not done the holding work here. So let me point this out to you. This smart pointer will be destroyed when it goes out of scope. And there are no smart pointers elsewhere. To protect this instance. Okay, so that is our entire simple demonstration. Let's see if there is anything else to add. Alright, let's continue. Actually, the rest is pretty much done. You will notice that we have already written that bound object. So we won't demonstrate it again. Let me further refine this for everyone. We need to write down these several methods for everyone. Object. And this is Bandu's wake. Then we hit. Then we copy it over. Put it here. It's normal that this explanation is taking a bit long, because this concept is probably being explained in detail for the first time here. It needs to be explained a bit longer. Okay, here we directly pass a z value. Then we pass it directly like this. Pass it. This function name. We'll just paste it here. The location of this function. Okay, so that should be fine. And this lambda is actually the same. We'll just write it like this. It's actually very similar to this smart pointer. It's not much different. Let's take a look. This should be BindWake Lambda. Okay, you'll see it's just like this. And it can be different from Bind Lambda, because it will hold a weak object's PDR. And as for this function, actually we'll just write something casually here. And this method, if you're interested, you can execute it. Not executing it is also perfectly fine. And this part, they should be called call myself your object. This should be VC Lambda. Let's create it. These are the two delegates. We execute it. Here. Okay? That's all for this lesson. Please test this part on your own. This is all very simple. We already wrote it for you earlier. We wrote 56 out of 12, 3, 4, 5, 60, 70, 8, 9. For the last two, just start the blueprint, then test by pressing the keys.